I bet you didn't know how Isaac Newton revolutionized our understanding of the universe. His name is synonymous with genius. Born in a world shrouded in mystery, he dared to question, to explore, to unravel the secrets of nature. His insatiable curiosity led him down paths untrodden, and his brilliance illuminated the world with groundbreaking discoveries. From the smallest particles to the grandest celestial bodies, Newton's influence permeates the very fabric of science. Imagine a world without the laws of motion, without an understanding of gravity. A world where the nature of light remained an enigma. This was the world before Newton, a world on the cusp of transformation. Newton's inquisitive mind, coupled with his unparalleled mathematical prowess, set in motion a scientific revolution that continues to reverberate through the ages. He didn't just discover laws, he crafted the very language with which we describe the universe. His legacy extends far beyond the apple that supposedly sparked his theory of gravity. Newton's work laid the foundation for modern physics, astronomy, and mathematics. He gifted us with the tools to understand the dance of the planets, the trajectory of a cannonball, and the very nature of light itself. His inquisitive spirit and relentless pursuit of knowledge continue to inspire generations of scientists and thinkers, pushing the boundaries of human understanding ever further. His work remains a testament to the power of human intellect, a beacon illuminating the vast expanse of the cosmos. This is going to blow your mind. If you don't like math but still appreciate science, then you need to understand Newton. While the story of the falling apple is often romanticized, it represents just a sliver of Newton's monumental contributions. His work was far more nuanced and complex, delving into the intricacies of calculus, the laws of motion, universal gravitation, and the nature of light. He wasn't just an observer, he was a masterful architect, constructing a framework for understanding the very laws that govern our existence. He was a man of intense focus, dedicating years to unraveling the mysteries of the universe. Newton's genius lay not just in his ability to observe, but in his capacity to synthesize information, to connect seemingly disparate phenomena, and to derive fundamental principles. He transformed the way we perceive the world, replacing superstition and speculation with reason and rigorous mathematical analysis. His work was a testament to the power of the human mind to unravel the complexities of nature, a triumph of intellect over ignorance. His exploration of optics revealed the true nature of light, demonstrating that white light is composed of a spectrum of colors. This groundbreaking discovery revolutionized our understanding of color and laid the groundwork for future advancements in optical science. It wasn't just about pretty rainbows, it was about understanding the very nature of light itself, a fundamental building block of our universe. From the vibrant hues of a sunset to the twinkling of distant stars, Newton unveiled the secrets hidden within the light that bathes our world. His development of calculus provided scientists with an invaluable tool for understanding change and motion, a mathematical language for describing the dynamic nature of the universe. Calculus wasn't just a set of equations, it was a new way of thinking, a powerful tool that unlocked countless possibilities in mathematics, physics, and engineering. From the orbits of planets to the growth of populations, calculus provided a framework for understanding the ever-changing world around us. It was a key that unlocked the door to a deeper understanding of the universe and its intricate workings. Why are there not more people talking about the profound impact of Isaac Newton's early years? Born in the hamlet of Woolsthorpe, Lincolnshire, in 1643, Isaac Newton entered a world on the cusp of scientific revolution. His childhood was marked by both tranquility and turmoil. His father, also named Isaac, passed away before his birth, leaving young Newton to be raised by his mother. This early loss undoubtedly shaped the young Newton, instilling in him a sense of independence and a thirst for knowledge.
He found solace in books, devouring texts on astronomy, mathematics, and natural philosophy, laying the foundation for his future intellectual pursuits. Despite a difficult start, Newton's innate curiosity propelled him forward. He displayed an exceptional aptitude for mechanics, constructing intricate models and devices that fascinated those around him.
His mind, like a sponge, absorbed information, constantly seeking to understand the workings of the world. He wasn't content with simply observing. He wanted to dissect, to analyze, to unravel the mysteries that lay hidden beneath the surface. His early education at King's School in Grantham further nurtured his intellectual curiosity. He excelled in his studies, demonstrating a remarkable grasp of mathematics and a keen interest in the natural world. His mind, like a finely tuned instrument, was poised to make a significant impact on the world of science.
He wasn't just learning, he was discovering, exploring the vast landscape of knowledge with an insatiable thirst for understanding. Newton's thirst for knowledge was not confined to the classroom. He spent countless hours exploring the countryside, observing the natural world with a keen eye.
He studied the movement of the stars, the changing seasons, and the intricate workings of nature. These observations, coupled with his voracious reading, laid the groundwork for his future scientific breakthroughs. He wasn't just a student, he was a scholar, an explorer charting the unknown territories of knowledge. I don't think people understand how Isaac Newton's time at Trinity College would shape the future of science. In 1661, Newton embarked on a new chapter in his life, entering Trinity College, Cambridge. This prestigious institution would prove to be a crucible for his genius, providing him with the intellectual resources and environment to flourish. Surrounded by some of the brightest minds of his time, Newton immersed himself in the world of academia, eagerly absorbing knowledge and engaging in intellectual discourse. He was a sponge, soaking up information from every available source, his mind buzzing with ideas and possibilities. At Trinity, Newton encountered the works of influential thinkers such as René Descartes, Galileo Galilei, and Johannes Kepler. These intellectual giants ignited his imagination, inspiring him to push the boundaries of scientific understanding. He wasn't just studying their work, he was engaging with it, challenging it, building upon it. His mind, like a furnace, forged new ideas from the raw materials of existing knowledge. The academic environment at Trinity fostered a spirit of inquiry and innovation. Newton thrived in this atmosphere, engaging in lively debates and discussions with his peers and professors. He wasn't just learning, he was contributing, shaping the intellectual landscape of his time. His ideas, like sparks, ignited the minds of those around him, setting in motion a chain reaction of discovery. He wasn't afraid to challenge conventional wisdom, questioning established theories and seeking new explanations for the phenomena he observed. This independent thinking, coupled with his rigorous mathematical approach, would become the hallmark of his scientific work. He wasn't just a student, he was a revolutionary, challenging the status quo and paving the way for a new era of scientific understanding. You need to watch this if you struggle with understanding the true impact of calculus. Newton's time at Trinity College marked a period of intense intellectual ferment. It was during this period that he began to develop his groundbreaking work on calculus, a mathematical framework that would revolutionize the way we understand change and motion.
This revolutionary new system, initially called fluxions, provided a powerful tool for analyzing continuous change, paving the way for advancements in physics, engineering, and countless other fields.
It wasn't just a new branch of mathematics, it was a new language for describing the universe. The development of calculus was not a sudden epiphany, but rather the culmination of years of intense study and reflection.
Newton's deep understanding of geometry, algebra, and the works of his predecessors provided the fertile ground from which his groundbreaking ideas sprang forth. He wasn't just inventing, he was innovating, synthesizing existing knowledge into a powerful new tool for understanding the world.
Calculus provided a powerful language for describing the dynamic nature of the universe, from the orbits of planets to the flow of fluids. It allowed scientists to analyze change in a way that had never before been possible, opening up new avenues of exploration and discovery.
It wasn't just about numbers, it was about understanding the fundamental principles that govern the universe. The implications of Newton's calculus were far-reaching, extending beyond the realm of pure mathematics.
It provided the necessary tools for understanding and predicting the motion of objects, laying the groundwork for Newton's later work on the laws of motion and universal gravitation. It wasn't just a mathematical theory, it was a key to unlocking the secrets of the universe. I don't think people understand inertia and the nature of motion. Isaac Newton's first law of motion, often summarized as the law of inertia, fundamentally transformed our understanding of motion. This law states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. This deceptively simple idea shattered the Aristotelian belief that a force was needed to maintain motion. Newton's insight was profound. Objects have a natural tendency to resist changes in their state of motion. The concept of inertia forms the bedrock of Newtonian mechanics. It explains why passengers in a moving vehicle lurch forward when it suddenly stops, and why a spacecraft continues its journey through the vacuum of space without the need for continuous propulsion. This intrinsic property of matter to resist changes in motion is a cornerstone of our understanding of how objects behave under various forces. Through this law, Newton laid the groundwork for a new era of scientific exploration. Newton's first law also introduced the idea that rest and uniform motion are equivalent states of equilibrium. This was a revolutionary departure from the ancient view that every motion required a cause. By establishing that an object in motion does not need a force to keep it moving, Newton opened the door to a deeper understanding of motion and forces. This principle is fundamental to the design of everything from simple machines to complex engineering systems. The law of inertia also underscores the importance of reference frames in studying motion. In a frictionless environment, an object's constant velocity is relative to its surroundings. Understanding this relative motion allows scientists and engineers to predict and control the behavior of objects in various contexts, from the trajectory of a thrown ball to the paths of interstellar spacecraft. Newton's insight continues to guide our exploration of the physical universe. You need to hear this if you're a physics enthusiast. Why are there not more people talking about the profound impact of Newton's second law of motion? Newton's second law of motion is perhaps the most mathematically rigorous of his three laws. It states that the force acting on an object is equal to the mass of that object multiplied by its acceleration. This elegant equation quantifies the relationship between an object's mass, the forces applied to it, and the resulting acceleration. It is a powerful tool that allows us to predict the behavior of objects under various forces. It explains why heavier objects require more force to achieve the same acceleration as lighter ones. It is the principle behind everything from the launch of a rocket to the braking of a car. By understanding this relationship, scientists and engineers can design systems that effectively manage forces and achieve desired motion. Newton's second law is a fundamental principle that underpins much of modern technology. Newton's second law also provides a framework for understanding the dynamics of systems with multiple forces. By breaking down complex interactions into individual components, we can analyze how different forces contribute to the overall motion of an object. This approach allows for precise predictions and control of systems ranging from mechanical devices to celestial bodies. The second law is a key element in the study of dynamics and the behavior of physical systems. The law's implications extend beyond simple linear motion. It also applies to rotational motion, where torque plays the role of force and angular acceleration replaces linear acceleration. This broader application makes Newton's second law a versatile and powerful tool in various fields of science and engineering. Understanding how forces cause changes in motion, both linear and rotational, is essential for the design and analysis of countless mechanical systems. I bet you didn't know how the forces that govern our universe work. The third law. Action and reaction in the universe. Newton's third law of motion is perhaps the most intuitively understood. For every action, there is an equal and opposite reaction. This law describes the mutual interactions between objects, emphasizing that forces always come in pairs. When one body exerts a force on another, the second body exerts an equal and opposite force on the first. This principle is evident in everyday phenomena, from walking to the recoil of a gun. The third law has profound implications for our understanding of interactions in the physical world. It explains why we are able to walk. Our feet push against the ground and the ground pushes back with an equal and opposite force, propelling us forward. This mutual interaction is also seen in the flight of birds and the operation of jet engines. The third law is a fundamental principle that governs the behavior of objects in contact. Newton's third law is crucial in analyzing the behavior of systems where forces are transferred between objects. For example, in the operation of rockets, the expulsion of gas out of the engine exerts a force on the rocket, while the rocket exerts an equal and opposite force on the gas. This interaction propels the rocket forward, demonstrating the practical application of Newton's third law in modern technology. The law's implications are far-reaching, encompassing a wide range of phenomena in mechanics and engineering. This law also plays a critical role in our understanding of conservation laws, particularly the conservation of momentum. In an isolated system, the total momentum remains constant, a direct consequence of Newton's third law. This principle is foundational in both classical and modern physics, providing a framework for analyzing collisions and interactions at all scales, from subatomic particles to galaxy clusters. Newton's third law continues to be a cornerstone of our understanding of the physical universe. This is going to blow your mind. The story of the falling apple, while perhaps embellished over time, encapsulates the essence of Newton's genius, his ability to connect seemingly mundane observations with profound scientific insights.
As legend has it, Newton, while sitting in his garden at Woolsthorpe Manor, observed an apple falling from a tree. This seemingly simple event sparked a chain of thought that would ultimately lead to his formulation of the law of universal gravitation.
The apple, a symbol of everyday nature, became a catalyst for a revolution in scientific understanding. Newton's inquisitive mind wasn't content with simply accepting the apple's descent as a given. He questioned why the apple fell straight down, rather than sideways or upwards. This simple question, driven by an insatiable curiosity, led him to ponder the nature of the force that pulled the apple towards the earth.
He wasn't just observing, he was questioning, probing the underlying mechanisms of the universe.
He began to consider whether the same force that caused the apple to fall might also be responsible for keeping the moon in orbit around the Earth. This bold leap of imagination, connecting the terrestrial with the celestial, was a hallmark of Newton's genius. He wasn't just thinking about apples, he was contemplating the very fabric of the cosmos.
This moment of inspiration, sparked by the falling apple, set Newton on a path of intense study and mathematical exploration. He delved into the works of Kepler and Galileo, seeking to understand the laws that governed the motion of celestial bodies. He wasn't just reading, he was synthesizing, building upon the work of his predecessors to forge a new understanding of the universe.
What's something people don't know about Newton's law of universal gravitation? It's a cornerstone of classical physics, and it states that every particle in the universe attracts every other particle with a force proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This elegant equation, F equals G times m1 times m2 divided by r squared, encapsulates the fundamental force that governs the interactions between all objects with mass. It wasn't just a mathematical formula, it was a revelation, a glimpse into the underlying structure of the cosmos.
This law reveals that gravity is not a localized phenomenon, but a universal force that connects all matter in the universe. From the smallest grains of dust to the largest galaxies, everything is bound together by this invisible thread of gravitational attraction. Newton's law provided a framework for understanding the intricate dance of celestial bodies, the orbits of planets, and the very structure of the cosmos.
The inverse square law, a key component of Newton's equation, explains why the gravitational force weakens rapidly with increasing distance. This explains why the Moon, despite its significant mass, exerts a much weaker gravitational pull on Earth than the Earth itself. The distance between objects plays a crucial role in the strength of their gravitational interaction.
Newton's law of universal gravitation not only explained the observed motions of celestial bodies, but also predicted the existence of Neptune, a planet later discovered based on its gravitational influence on Uranus. This predictive power solidified the law's status as a fundamental principle of physics, demonstrating its ability to unveil the hidden workings of the universe.
This is why you need to understand gravity. Newton's law of universal gravitation revolutionized our understanding of the cosmos by unifying the terrestrial and celestial realms. Before Newton, the laws governing the motion of objects on Earth were considered separate from those governing the movements of celestial bodies. Newton's insight was to recognize that the same force, gravity, was responsible for both. This unification was a monumental leap forward in scientific thought. This unifying principle had profound implications for our understanding of the universe. It meant that the same laws of physics applied everywhere, from the falling of an apple to the orbits of planets around distant stars. The universe was no longer a collection of disparate phenomena, but a unified system governed by fundamental principles. Newton's work laid the foundation for a deeper understanding of the cosmos. Newton's law of gravitation provided a framework for understanding the formation and evolution of stars, galaxies, and even the universe itself. It explained the delicate balance of forces that hold celestial bodies in their orbits, and the processes by which these structures evolve over cosmic timescales. The law became a cornerstone of astrophysics and cosmology. The impact of Newton's work extended far beyond the realm of science. It influenced philosophy, theology, and even the arts, inspiring new ways of thinking about the universe and humanity's place within it. Newton's legacy continues to shape our understanding of the world around us, a testament to the enduring power of his scientific insights. Am I the only one that didn't know how Isaac Newton revolutionized our understanding of light? Isaac Newton's insatiable curiosity extended beyond the realms of motion and gravity to the enigmatic nature of light itself. In the 17th century, the properties of light remained largely a mystery, with prevailing theories often rooted in ancient philosophies. Newton, however, approached the subject with his characteristic blend of meticulous experimentation and rigorous mathematical analysis. He wasn't content with simply accepting existing explanations. He wanted to see for himself, to unravel the secrets hidden within the luminous fabric of the universe. His fascination with light led him to conduct a series of groundbreaking experiments meticulously documented in his seminal work, Optics. He used prisms, lenses, and mirrors to dissect and manipulate light, carefully observing its behavior and drawing conclusions based on empirical evidence. He wasn't just theorizing, he was experimenting, probing the nature of light with the precision of a surgeon. Newton's approach to optics was revolutionary for its time. He rejected the prevailing Aristotelian view that color was a modification of white light, instead proposing that white light itself was a composite of all the colors of the spectrum. This radical idea, supported by his meticulous experiments with prisms, overturned centuries of conventional wisdom and laid the foundation for modern color theory. He wasn't just challenging existing theories, he was rewriting the rules of the game. His experiments with prisms demonstrated that white light could be separated into its constituent colors and then recombined to form white light again. This seemingly simple demonstration had profound implications for our understanding of light and color. It revealed the hidden complexity within the seemingly pure white light that bathes our world. Newton's work transformed our perception of color, from a mysterious property to a quantifiable and predictable phenomenon. I bet you didn't know how Newton's prism experiment changed our understanding of light. Newton's most famous optical experiment involved passing a beam of sunlight through a prism. He observed that the light emerging from the prism was not simply refracted, but separated into a continuous spectrum of colors, ranging from red to violet. This demonstration, elegantly simple yet profoundly insightful, provided concrete evidence for his theory that white light was a mixture of all colors. He wasn't just observing a phenomenon, he was decoding the very essence of light. He meticulously documented his observations, carefully measuring the angles of refraction for each color and demonstrating that the different colors corresponded to different wavelengths of light. This precise quantification of the relationship between color and wavelength was a groundbreaking achievement, laying the groundwork for future advancements in spectroscopy and the study of light's interaction with matter. He wasn't just describing the rainbow, he was quantifying it, transforming it from a beautiful spectacle into a scientific phenomenon. Newton's work with prisms not only revealed the composite nature of white light, but also demonstrated that the colors of the spectrum were fundamental and could not be further decomposed. He showed that when a single color of light was passed through a second prism, it remained unchanged, proving that the individual colors were pure and not mixtures of other colors. This observation further solidified his theory of color and laid to rest centuries of speculation about the nature of light. His meticulous experiments and detailed analysis transformed the study of optics, establishing it as a rigorous scientific discipline. He wasn't just playing with prisms, he was laying the foundation for a new era of scientific understanding, paving the way for future discoveries in fields ranging from astronomy to medicine.
Newton's meticulous experiments and detailed analysis transformed the study of optics, establishing it as a rigorous scientific discipline. He wasn't just playing with prisms, he was laying the foundation for a new era of scientific understanding, paving the way for future discoveries in fields ranging from astronomy to medicine. If you're a science enthusiast, then you need to know about Newton's contributions to optics that extended beyond his groundbreaking work with prisms and color. He also revolutionized the field of astronomy with his invention of the reflecting telescope.
At the time, refracting telescopes, which used lenses to gather and focus light, suffered from chromatic aberration, a distortion that caused different colors of light to focus at different points, resulting in blurry images. Newton recognized this limitation and sought a solution.
His ingenious solution was to replace the refracting lens with a concave mirror. This seemingly simple innovation had a profound impact on the field of astronomy. The reflecting telescope eliminated chromatic aberration, allowing for clearer and more accurate observations of celestial objects.
He wasn't just tinkering with telescopes, he was opening a new window on the universe.
Newton's first reflecting telescope, built in 1668, was a small but powerful instrument, demonstrating the feasibility of his design. This prototype, though modest in size, represented a giant leap forward in telescope technology, paving the way for the construction of larger and more powerful reflecting telescopes that would revolutionize our understanding of the cosmos.
He wasn't just building a telescope, he was building a bridge to the stars.
The reflecting telescope became the dominant design for astronomical instruments, enabling astronomers to peer deeper into the universe and make groundbreaking discoveries about the nature of stars, galaxies, and the vast expanse of space.
Newton's invention, born from his deep understanding of optics and his innovative spirit, continues to shape our exploration of the cosmos, a testament to his enduring legacy in science and technology.
He wasn't just an optician, he was a visionary, expanding the horizons of human knowledge and inspiring generations of scientists to reach for the stars.
Am I the only one that didn't know about the incredible impact of Isaac Newton's involvement with the Royal Society? In 1672, Isaac Newton, already renowned for his groundbreaking work on calculus and optics, was elected a Fellow of the Royal Society. This prestigious scientific organization, founded just a few decades earlier, provided a vibrant hub for intellectual exchange and the dissemination of scientific discoveries. Newton's involvement with the Society marked a significant chapter in his life, offering him a platform to share his ideas and engage with some of the leading scientific minds of his time.
He wasn't just joining a club, he was entering a community of scholars, a crucible of intellectual ferment. The Royal Society, with its motto Nullius in verba, Latin for take nobody's word for it, championed the importance of empirical observation and experimentation. This emphasis on evidence-based reasoning resonated deeply with Newton's own scientific philosophy.
He found within the Society a kindred spirit, a group of individuals dedicated to unraveling the mysteries of the universe through careful observation and rigorous analysis. He wasn't just attending meetings, he was participating in a revolution, a shift from dogma to data.
Newton's contributions to the Royal Society were substantial. He presented his groundbreaking work on optics, sparking lively debates and discussions among the Society's members. His demonstrations of the prism experiment and his explanations of the nature of light and color challenged established theories and ignited new avenues of inquiry.
He wasn't just presenting his findings, he was sparking a dialogue, pushing the boundaries of scientific understanding. In 1703, Newton was elected president of the Royal Society, a position he held for the remainder of his life. Under his leadership, the society flourished, attracting some of the most brilliant minds of the age and solidifying its position as a leading centre for scientific advancement.
He wasn't just leading a society, he was shaping the future of science, fostering a culture of inquiry and innovation that would continue to inspire generations of scientists.
What's something people don't know about Isaac Newton? While Isaac Newton is celebrated for his contributions to physics, mathematics and optics, a lesser-known aspect of his intellectual pursuits lies in his deep fascination with alchemy.
Newton's interest in alchemy, though seemingly at odds with his scientific rigor, reveals a different facet of his intellectual curiosity. He wasn't just a scientist, he was an explorer, venturing into uncharted territories of knowledge.
Newton dedicated a significant portion of his life to alchemical experiments, meticulously documenting his procedures and observations in numerous notebooks. He believed that the secrets of the universe were hidden within matter, waiting to be unlocked through careful experimentation and manipulation.
He wasn't just following recipes, he was experimenting, probing the nature of matter with the same intensity he applied to his scientific pursuits.
His alchemical studies, though ultimately unsuccessful in achieving the traditional goals of transmutation, provided him with valuable insights into the properties of matter and chemical reactions. His meticulous observations and experiments, though not always leading to the desired outcomes, contributed to his growing understanding of the physical world.
He wasn't just searching for gold, he was searching for knowledge, seeking to understand the fundamental building blocks of the universe.
Newton's interest in alchemy, though often viewed as a curious anomaly in his otherwise scientific career, reflects the broader intellectual landscape of his time. Alchemy, though now considered a pseudoscience, was an integral part of the scientific revolution, stimulating inquiry and experimentation that ultimately contributed to the development of modern chemistry.
Newton's alchemical pursuits, though not aligned with his most celebrated achievements, offer a glimpse into the complex and multifaceted mind of a scientific giant.
Why are there not more people talking about how Isaac Newton's relentless curiosity reshaped our understanding of the universe? From his humble beginnings in Woolsthorpe to his esteemed position as President of the Royal Society, his journey was marked by groundbreaking discoveries that reshaped our understanding of the universe.
He wasn't merely an observer of nature, he was an active participant, dissecting its intricacies and revealing its underlying principles. His work was a symphony of observation, experimentation, and mathematical brilliance, each note contributing to a harmonious understanding of the cosmos.
His laws of motion and universal gravitation laid the foundation for classical mechanics, providing a framework for understanding the movements of objects both on Earth and in the heavens. These laws weren't just abstract concepts. They were tools that enabled engineers to design bridges, architects to construct buildings, and astronomers to predict the paths of celestial bodies.
Newton's work transcended the boundaries of academia, impacting the practical world in profound ways. He bridged the gap between theory and application, demonstrating the power of scientific understanding to shape our physical reality.
His optical experiments revealed the true nature of light and color, overturning centuries of misconception and establishing the field of optics as a rigorous scientific discipline. His invention of the reflecting telescope revolutionized astronomy, providing a clearer view of the cosmos and enabling astronomers to make groundbreaking discoveries.
Newton's impact on science was not merely incremental, it was transformative, shifting paradigms and opening up new avenues of exploration. His contributions to mathematics, including the development of calculus, provided scientists with powerful tools for analyzing change and motion.
Calculus became the language of physics and engineering, enabling researchers to model complex systems and make precise predictions. Newton's mathematical innovations were not just theoretical exercises. They were instruments of discovery, empowering scientists to unlock the secrets of the universe. I bet you didn't know how much Isaac Newton's legacy extends far beyond the scientific community. His work has permeated our culture, influencing our language, our philosophy, and our understanding of the world around us. The very phrase Newtonian physics evokes a sense of order and predictability, a testament to the profound impact of his ideas on our perception of the universe.
He wasn't just a scientist, he was a cultural icon whose ideas shaped the intellectual landscape of his time and continue to resonate today. His emphasis on reason and empirical observation helped usher in the Age of Enlightenment, a period of intellectual and cultural transformation that emphasized the power of human reason and the importance of scientific inquiry.
Newton's work became a symbol of this new era, inspiring thinkers and artists to explore the world with a renewed sense of wonder and a commitment to rational inquiry.
He wasn't just a scientist, he was a catalyst for change, igniting a revolution in thought that continues to shape our world.
His scientific achievements continue to inspire generations of scientists, engineers, and mathematicians. His meticulous approach to experimentation and his rigorous mathematical analysis serve as a model for scientific inquiry, reminding us of the importance of careful observation, precise measurement, and logical deduction.
Newton's legacy isn't just about the past, it's about the future, inspiring future generations to continue the quest for knowledge and understanding.
From the smartphones in our pockets to the satellites orbiting overhead, Newton's influence can be seen in countless aspects of modern technology. His laws of motion and gravitation are essential for understanding the flight of aircraft, the operation of GPS systems, and the design of countless other technologies that shape our daily lives.
Newton's work wasn't just about understanding the universe, it was about transforming it, harnessing the power of scientific knowledge to create new possibilities and improve the human condition.
His legacy continues to unfold, shaping the world we live in and inspiring us to reach for the stars.